Right, okay guys, all I've done is just assemble the 360 power supply as you saw in the previous video, which I will link in a card or at the end of the video so you guys can see. At the moment you can see it's turned off, there's nothing going on. I've just double insulated taped it shut. The only thing that's missing on here, which is what I'm kind of worried about, is the RFI shield at the bottom, which connects with two blue capacitors at the main side to the ground on the output side. So I'm not sure if it's just for shielding or whether it remains referenced to ground. I don't know, and that's why I'm a bit worried about plugging this thing in to see what happens. So let's have a look, shall we? I have my 2-pin 360 fat or elite power supply cable, which is live. There's no isolation transformer, which is dangerous, so don't do this at home guys if you've mucked about with electrical stuff. Just want to see if this thing works or not. So if it goes bang, it shall allow for an interesting video. So we're on, and we have the light that we expect. That's good, because that shows it standby. That's excellent. That's exactly the result I wanted. So let's unplug from the mains, and that light is still on. Let me just focus on my camera. The light is still on. It's still on. It might be because of the large output capacitors that I put in. We'll see how long it takes to actually go off. But as I say, that indicates that we're at a standby stage, which is what we wanted, because we've not connected any output wires or anything, which I've looked at the configurations for. So I think I've got it down to a T. So that will be the next step in this video. So we'll connect some output connectors. There are 1, 2, 3, 4, 5 wires, one of which is a 5-volt connector, which is always on. There's another 12-volt enable line pin. There's a 12-volt output pin and 2 grounds, which are linked together. So we'll go through that in the next stage. And now it's gone off, so that means the output capacitors are now drained. So let's now jump in to connecting the output of this power supply, which is up here, and then seeing if we can enable the 12-volt, because obviously when you power on the 360 it sends a signal back to the power supply to actually enable the power. It's like a soft power on function. So we'll do that next. So let's have a look. Right, now we've got that down and it's not gonna blow up, which is fan-bloody-tastic. I'm gonna just take this tape off. Let me see if I've got a straight edge or something that I can just cut that straight off. Can't be asked to pin it off. And what we'll do, we'll look at that at a later time, doing it properly and all that jazz. It was just for safety, just while I was plugging it in and stuff. I don't know what I've done with the screws. I took them off and just got rid of them. I don't know what I've done with them. Just make sure it's completely off. And obviously I'll show you the dangers in high voltage power supplies. Number one, don't dig them with metal screwdrivers. Number two, touch places that are not going to be too high in voltage. Number three, this one's a bit of a pain because it's upside down. You can touch the secondary side because it's only 12 volts, a few amps. But the dangerous side you do not want to touch, if I can get this up without touching it, is that big bastard there. And, oh shit, I'm off frame, sorry. Is that big bastard there, and this side because it's all the input. So, let me see what a capacitor is. Right, those two connections. Oh, I'm out of frame. Sorry, I haven't got my zoom camera, do apologise. It's, I'll try not to short it out like that. Two connections, I think. Where are we? 1 and 2, right? So let me just get my multimeter, as you Americans would call it. Let me get that off to the side. Let me bring that in there so you can see it, not glaring, which is good. I haven't got my actual touchy probes. Actually, I might do that because I don't be clipping things on, but the problem is I don't know what I've done with those probes. Okay, let's just do it with those probes. So basically, you want to double check before you touch any electrical equipment. Put it on to DC because it's obviously after the AC input comes enough. And what 2 did I say it was? I think it was 1 and 2. I can see 1 and 2. 2.3 volts. It says minus. I've got my probes back to front, but at least you know you can't touch it. It's relatively safe. So then you know you can just carry on touching the underside of this because you know it's not dangerous high voltages. But if you've just unplugged the thing, and again, be careful, don't be using crocodile clips to do what I just did. I'm a professional. Not. So yeah, oh crap. So now we got that far. Recommendation, by the way, if you've not seen my YouTube video on this particular digital multimeter from EEV blog, the BM235, it's about 120 quid UK. Definitely bloody worth it. Anyway, get one if you haven't got one, or if you've got a load of shitty meters, definitely worth buying and paying out a little bit of money for that. So at least we know now this is A, discharged, and B, we're ready to work on it. So what I'm going to do next is, as I said, I've got the connections now. I know we don't have to worry about the RF shield that was on the bottom, thank God. And we are labelled. Let me see if I can go down just a tad, because you might be able to see just that little bit better. And let me just go up to there, and then I'll put my autofocus on. There we go. So as you can see, I've got, let me use my pointer again. So that is V plus, I'm guessing is plus 12. That is ground, and that will account for all grounds. That says, let me put my focus on. That might be better money. 5 volt VSB, so that's the 5 volt plus rail. There you go, ground, V plus. It's actually marked with the colours of wires as well. VSB, 5 volt VSB red, V plus wire yellow, ground B black, and there is another one. There is power blue. See that in the middle? Power blue. So 1, 2, 3, 4, 5 connections, 5 volts. That I think is the 12 volt sense line to switch the power supply on. I think we just use the 5 volts. And the one localized ground for all. It does say 5 volt ground. Oh, okay, I see. So it's 2 separates. That's 5 volts ground for the 5 volt lines. That's 12 volts. That's 12 volts. And that would be the 12 volt return. So now we know what we're doing. I'm now going to get some wires, attach them up, and see if we can get this thing actually to power on. Because when you power it on now, like I showed you, it will literally just stay as a as standby, because it's waiting for the signal to say, "Hey, turn me on." Not like that. Come on, grow up. So we'll go forward and do that. I might clean those solder joints anyway. You see all the flux residue and all that. I keep turning my zoom on and off. Zoom, autofocus. So there's a little bit of crust around those where I've not taken the flux off, but it's not touching anywhere where it shouldn't, although that does look like it could be an issue. Let me get my pointer. That there, see that? We have a solder blob, and that flux can be conductive, so for that reason I'm going to clean that as well. So let's go forward and do that. Okay, I found a guide on the internet, as you can see here. Basically shows you how to switch on this power supplier specifically. I'm not sure if this applies to the old Xbox power supplies as well. I'm not sure, but this one is actually for this power supply. So we can now have a look at this wiring guide. As you can see, ground goes to ground, obviously. and that references all grounds. So all the grounds in here are the same. 12 volts is obviously for 12 volts, and the 5 volt line, if you see here, they've actually put a 1 kilo ohm pull-up resistor to the 12 volt cable, 12 volt sense, because that's the 12 volt sense line. That's not the 12 volt power line. Oh, hang on. One moment. So the blue 12 volt enable. Right, okay, so they're not showing the 12 volt line on here. Sorry, I got a bit confused there. So ground, 12 volt sense line, 5 volt, which is always on, and then that's a 1k pull-up resistor, just to limit any current in case there's any sort of huge current that's drawn to the actual 12 volt. Start again, it's getting confusing. Ground, that's the actual 12 volt power supply that we require on the output, which is off because it's on soft power on. 5 volt power supply, which is always on, and a 1 kilo ohm pull-up resistor to the 12 volt sense cable. So that's how I'll read that. I'm not sure if that's correct. It seems logically fine. I'll have to find myself a 12k. 12k? No, 1k resistor, just to drop from the 5 volt line to the 12 volt sense. Obviously that makes sense, otherwise, you know, there's no point putting on the actual 12 volts, is it? You know, they're both 12 volt lines, so who cares? So let's go on to actually doing that then. So we'll follow that as a guide. I said I found it on the internet. It's the only one I can see that references this power supply specifically, and obviously I haven't found any others, so we'll just go with that. So what I'm going to do now, again, I'm going to get up close and personal because I'm going to be soldering. So let me get down on it. Get down on it. Right. Straighten up the camera because it's a bit wonky. Okay. And as you can see, let me just point to those. So that's the ground. That's also the ground. I think that's the 12 volt, and that's the, no, that's ground. I don't know. Well, you saw from the other video what it was. So let me grab some wire. Actually, should we? No, I'm not going to plug it in first because we're going to be exposed, aren't we? I'm going to put the wires on first then. What's that little bit of crap on there? Where is it? There. Get. Don't know where that came from. So let's grab some wires and let's have a look, and we'll hook those up. We'll measure the voltages, and good job I've got my crocodile clip so I can just attach to the wires without actually having to touch anything. So let's do that and get back to this and end this video ready for the actual 360 unit itself putting together. And also we're going to have to mod the power pins on the motherboard of the Xbox 360 Slim as well, because obviously we're going to be manually sort of wiring it up ourselves because I stupidly threw the cable away. So, but that reminder, kids, don't throw stuff away because you might know when you never might need it. Even though you might not think you'll need it, you probably will. So let's get some wire and come back to this. Okay, so what we've got then, I've just checked the continuity on the ground points. This is the ground, and then there's the 5-volt ground. So if I show you on the meter, if I put it onto continuity setting, as you can see there, and I use my red wire, and I'll show you exactly what I'm doing. Let me focus. There we go. So, get this crap off. So there was another ground. That's the. Let's have a look again, because I keep forgetting. Should write this stuff. So that's ground with the black wire coming out of it, and you see there it says 5-volt ground, just underneath. So if we take a look to see if they are linked together, put it on continuity, as I said, and what we'll do, let me put the light on it. Maybe my battery's dying. Anyhow, you guys can see that. So when you hear the beep, it means there's a connectivity. There's a connection. So that'd be where our wire's coming out from, and that'd be the other ground here. And as you can see, it's not connected. Not connected at all. And my battery's going on my meter, you can see it flickering. But anyhow, yeah, so I'm not sure about that. I mean, we don't really need that at this moment in time anyway. So we have the connectors that we need to have just to run the test. So this effectively is the 12-volt ground. So we need the 12-volt power, which is that hole there, which will be this wire. Let me show you soldering that again. What I might do is actually just run through this lot and time lapse it, because I'm sure you guys don't want to sit through the whole lot. Alright, okay, so at least my tip's not blackening up now like in the previous video, so that's good. It's just a shitty tip. Anyway, let's put some molder solder onto here like so. Hopefully it fits without no additional modification. Let's see if it goes in. Let's move these components out of the way. And would you look at that? There's not. Might be a bit too much solder on there. I say it doesn't matter how much solder you've got on the connector, as long as there is solder on it, we'll be fine. There's still quite a bit of solder on there, so let's get rid of that. Which is this one here. So that's why it's effective to actually clean all the solder off holes that you're going to be soldering, because at the end of the day you're going to end up with problems like so. So that goes straight in and end up breaking the tabs as well, so you've got to be careful. So let's get my solder. Which is this one here. Go. So now we have that all set up. So this yellow wire here is our power on. This is our 12-volt ground, and this is our 12-volt line. So what I need to do now is get a 1 kilo ohm resistor from my junk box, because actually, I'll tell you what, I think I've got some up here, out the way, up the way. No, I do not. Okay. I might have some in my junk bins over here. So 1K resistor. There's all my caps. There's all my caps. What about the other one? Resistor, where are you, resistor? I've got a box of resistors somewhere and I think it might be out of reach. Hello, resistor. I need your resistor. You like sunshine. What's that down there? That's caps. Resistor. I need a 1 kilo ohm resistor. Right, yo. Just gonna call for some. Get out all my crap. I have got a resistor box, and obviously I didn't plan this video very well, so my apologies. That's not got them in either. I had a small box with resistors in it. There it is. Sorry about this, guys. Would have been a bit of a better video, but I'm just going to jump forward on this lot. So what have we got there? Axle metal film, 100 ohm. What's that? 330 ohm, 300 ohm, 10k, 5 ohm, 6 meg, 4 ohm, 500k, 1 kilo ohm. There we go. Exactly what I was looking for. Right. And just to make sure it is 1 kilo ohm, because I am colourblind, as I've said before, we shall test, because we can. So we've gone to resistance, which is that out of that one on one leg, and one on the other. Spot on, look at that, 1 kilo ohm. Excellent. So as I said, on our 5 volt output, which is didn't zoom. Thing is, there we go. 5 volt. So from this one, which lucky enough I've already tinned. I'm not going to shorten the wires on it because I can't bother. Let's get the old pins out again. Focus on that. Put it underneath. Put that there. Put an equal bit of solder on the end of this resistor. Like so. And then, jeez, that is hot. Oh my god. Now I've got to solder backwards, so let me turn that round that way. Might be a bit better for me to, or not, get onto. Put those together. That'll do for now. It's only for testing purposes anyway. It's only a test. Yep, so that's our 5 kilo ohm resistor. Sorry, 10 kilo ohm, 1 kilo ohm resistor there, and then we're going to be putting that onto the power, which is that one. Might actually just solder that on there, and then we should have the power supply come on, and we should have the 12 volts output, he says. go. So now we'll be testing 12 volt, 12 volt return. Okay. Then we'll put it back in its case because I don't trust myself. I'll end up blowing myself up. So pop it back into here. And obviously there's a fan on this as well, so we can tell if we've got power to the power supply. And we have a nice little hole there. We'll just guide that through. Bend the wires around slightly. Connect the, what do you call it, thingamablob. 12 volt fan, because obviously we want an indication that, other than the LED, to show that this is working. Come on, you son. I love these little piss ass connectors. So much fun when you're trying to put one. Get in there, you bitch. Okay, well I skipped all that because it was just getting a bit long. I've retaped it up. I've got a 1 kilo ohm resistor here just to power enable the unit. And what I'll do is I'll just take off the auto zoom because it's going to be warbling like a bitch. Got our meter set to DC, so obviously that's what's going to be outputted on this here, say power supply. Yellow being the 12 volt plus, and that one being the ground. So it all goes pear shaped. It will be interesting. So let's go plug it in, see if it goes bang. It doesn't go bang. Okay, 15 volts. It's not too bad. We've got a fan running. I've got no load on it, so obviously I'm not going to have, well, it's sticking up. Good at it. I'm not going to have doodah. So let's see what the light is. There we go. Good. Green. So we know that that is absolutely perfecto. Although the voltage is dropping quite a lot. It's supposed to be 12 volt. Wonder why we are dropping voltage, because that's not good. That's not good at all. Let me unplug. So it's basically like we're off. Let me just check that. The resistor's not hot. Okay. Let me plug it in again initially. So it jumps up to 15, which is quite a lot. 14. And so it should be 12 volt regulated. 13. It's steadily dropping, which is not the required result. Maybe because it's not loaded, maybe there has to be a load on the power supply, maybe? I mean, it's dropping down slowly this time. Can't hear if the fan off. The resistor's not getting hot, so it's not providing a load of any kind. Let's see what happens when we first power it on, see what the LED light shows us, because it might be going into a fault mode, might be an issue somewhere. So let's have a look. Well, it's loaded down because the LED's gone off. See it the right way around. Okay. So red. So that means there's a fault. Sorry. So it's either gone to overcurrent protection or over voltage protection, something like that. Let's get rid of that resistor and see if we still get the 12 volts. Okay. It must be loaded down because... Okay, let me just cut that resistor out of circuit. Okay, get those wires separate. Still keep an eye on the voltage. It's still showing 13, that's really strange. So now we shouldn't have any. So we're still showing red. Sorry. I think we have the problem. Not unless what it was, this power supply failed initially. But we're still showing a voltage drop. Just what I love about electronics. Issues. V plus was to 12. Oh, don't short it out. Wait. I'll have to do some research into that and find out. So I'll call that the end of this video. It's been super long as it is already. Christ.